Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
So in this video, I really want us to focus in on how do we know if our numbers, or how certain are we that our model is correct? And there's this idea, now we know how to measure uncertainty. We've been doing that now for a while, but the question is how confident are you in the measurement? So that's like a big idea, right? The simplest model gets you the right answer, correct? Not always. So this is sometimes more difficult when you don't know what the right answer is. So let's take a look at two examples of two data sets. So if you look at the first data set right here, notice how the line of best fit intersects all the data. That makes us pretty confident that when we're up here, somewhere up in here on the graph, that it would predict something when you're up 10 or something like that. But if you look at the second model over here, you'll notice that the data doesn't intersect all the data points. So it's not going to be as strong of a certainty. And the way we do this is we have a graph, or a table I should say. We've got this table right here. On this table, what we have is, if we have up here in the top a high probability, this is like really, we are very confident. So it's determining confidence in prediction. And way down here, we are very unconfident. And so what things go into these two boxes? And what goes into those two boxes are these, all right? So I left this blank in your notes. I want you to copy that down. You've got the considerations. And the first one is the best fit line is near the center of nearly all the data points. Okay, that's a good thing, right? Or the best fit line is near the edges of many of the data points. So that makes it less, all right? But then it goes on this axis, if your predicted value was within the data range. So you make a prediction and you see what the answer is. You make a prediction and you get that answer, and all the points are together, you have a very high probability that this is a good idea. Got it? And if the predicted value is near the data range, medium high. And if it's far from the data range, all we can do is say medium. But in the second row here, now the best fit line isn't exactly awesome. We can only say medium high even when the predicted value is good. And then we can keep going down here to medium low. Okay? And then this last one, I'm sure is that important. We won't hardly ever use these two. But this is if there's like new physics to consider, that so it may no longer apply. This happened with like Albert Einstein, theory of relativity, and all kinds like that. That the whole laws of physics changed. So we will really focus on the first two rows, if you will, of this chart. And if you look at the graphs surrounding here, you can see that these all fit the data points. But this one, the second one, you see, this is where they're on the edges. So that's what the second one looks like right here. So the best fit line is near the edges of many of the data points. And this is where they are the same. And in this case, and then on the top here, the top three, is what happens if the data range is far from the prediction, if you're not getting close. So let's say on this first one, you get right on the line. I'm showing it's coming behind the screen, but it's right here on the line. Here, it's a little bit off the line, right? And here, it maybe is, right off the line. You're not getting the predicted value. What are you going to do? And that's what the three graphs represent on the top. So that's how you can determine the confidence in your predictions. Once you have that graph, you then make a prediction. Once you make a prediction, then you can do the top graph. The graph itself is going to give you, if you will, row one or row two. But then you're going to have to make a prediction, test it out. Say what happens if I do 60 centimeters or something like that, or whatever the thing you're measuring, and then see what that data point is. And if it's way off, you're all the way over here. If it's spot on, you're all the way to the left. Hey, Houston,